What's up, stats? This is the last lesson for this week. Well, it's more like review, but we're going to be going through the bell work, review everything that you've learned this week. So that's 3.1, basics of probability, 3.2, conditional and multiplication rule, 3.3, the addition rule. We're going to be reviewing those lessons. I have 5 examples for you that you more than likely, by more than likely, I definitely say probably will be on the actual quiz so that you can be adequately prepared for today's quiz. Let's get started. This is the first one right here. You roll a 6-sided die. Find the probability of each of the following scenarios. All right. For A, rolling a 4 or a number greater than 3. So if I say probability of rolling a 4 or x is greater than a number, or x greater than 3, a number greater than 3. Now, can I roll a number? Let's pay very close attention. This has to do with mutually exclusive events. Can I roll a number greater than 3 that is 4? And that is a yes, which means I have to subtract the number, subtract the outcome that is a 4 and also greater than 3. So I'm going to put that in my formula here. So this is going to be probability of 4, then plus the probability of a number greater than 3, and then minus the probability of 4 and that number greater than 3. Okay, so what does this equal? What's the probability of a 4? This is going to be 1 all over 6. What's the probability of a number greater than 3? Well, I have 4, 5, and 6. Why am I not including 3? It's not equal to. So if it's not equal to, you're not going to include it. So you have 4, 5, and 6. That's 3 out of the 6-sided die numbers, which is 6. So you have 3 out of 6 total options. How many numbers are a 4 and greater than 3? Well, there's only one of them because 4 itself is greater than 3. So there's one number that is a 4 for itself that is greater than 3. So that means I'm going to put 1 out of 6. What does this simplify down to? What is 1 plus 3? That is 4 minus 1, which is 3. So this is 3 out of 6, which of course is 0.5. Perfect. Let's go to B right here. Okay? Rolling a number less than 5 or an even number. Now, ask yourself a question. Can you roll a number less than 5 and also at the same time get an even number? Yeah. You can have a 2 and that's less than 5. You can get a 4 and that's less than 5. So that means these do have an overlap, which means it is not mutually exclusive, which means I will need to make sure I subtract that overlap there. So the probability of x being less than 5, plus the probability of an even number minus my overlap probability of a number less than 5 and that number also being even. How many numbers are less than 5? 1, 2, 3, 4. I'm not going to include 5 here because this 5 is not equal to. It's less than. So 1, 2, 3, 4. So only 4 numbers are less than 5. So that means I'm going to do 4 out of 6 plus. How many are even? 2, 4, and 6. So 3. So that means 3 numbers out of the 6 total die, 6 total numbers is even, minus how many numbers are less than 5 and even? Okay, less than 5 and even. Well, how many numbers are less than 5? 1, 2, 3, and 4. How many of those numbers, 1, 2, and 3, 4, are even? Well, half of them are. Excuse me, so half of them are, yes. So that means I'm going to put 2 all over 6. Let's reduce it down. This is going to be 4 plus 3 is 7 minus 2, which is 5. And then this is 6. And so this actually reduces down to a fraction, 5 over 6, which, you know what, I'm not even going to do the fraction right now. I'm just going to leave it as a fraction. I'm not going to do the decimal. It does give you a decimal, obviously, but I'm not going to do the decimal. I want to leave it there as a fraction. Let's do C. C, rolling a number, probability of rolling a number, which in this case it's 6, or an odd. Can a 6 be an odd? No. So is this mutually exclusive? Yes, because there is no overlap. You cannot have a 6 and an odd number. So this is the probability of 6 and then plus the probability of an odd. Okay. Now, what does that equal? How many numbers are 6 on a 6-sided die? Obviously, just 1. How many odds are there? There's half of them are odds, so 3. So this is 4 out of 6. This reduces down to 2 out of 3, which is also the same thing as 0.667, or 66%. All right, so that's the first one. You'll definitely see something like that on your homework quiz. Make sure you get it, or not your homework quiz, your actual quiz. Make sure you get it down so you can actually reference this during your quiz. Let's erase. All right. Let's go to A. Standard deck of 52 cards. One card is selected from the deck. Compute the probability that randomly selecting a 10 or a 4. Now, does a 10 have anything to do with a 4? You should say no. So that means there's no overlap. So we're going to find the probability of 10 plus the probability of a 4. What's the probability of a 10? How many 10s are there? There's 4 10s out of 52 cards. How many 4s are there? There's also 4 4s out of 52 cards. So this equals 8 out of 52. And this will give me 2 out of 13. I'm going to leave it as a fraction there. Let's go to B. So compute the probability of randomly selecting a 10 or 5, 10 or 4 or 5. And just because it has multiple ors doesn't mean anything. You can still just add over and over and over again. Now the cool thing is this, guys. Does a 10 have anything to do with a 4? No. Does it have anything to do with a 5? No. But here's another cool thing. You ready? I already know the probability of a 10 and a 4. Since I already know the probability of a 10 or a 4, I really just need to take this probability. So probability of a 10 or 4 or 5. It really is this probability, which I just found, 2 out of 13. Okay, 2 out of 13. And then I just need to add on this 5. What's the probability of selecting a 5? Well, that's 4 out of 52. So I just add 4 out of 52. Now, obviously, I can't combine these right now because they're not common denominators. But I can combine them shortly. Okay, I can combine them either by making that a common denominator or simplifying the 4 out of 52. So I'm actually going to simplify the 4 out of 52. So this is plus, divided by 4 is just 1, and then divided by 52 divided by 4 is 13. So then that is 1 plus 2, which is 3 out of 13. So that is probably the fastest way to do it, okay, where I don't need to necessarily think, okay, well, there's 10 4s again, there's 4 10s, there's 4 4s, and there's 4 5s. I really just need to take that probability and move it right there because I already know the probability of 10 or getting a 4. And I can put it right there and then just tag on the, okay, plus 4 out of 52 because there's 4 5s out of 52 card deck. That's the easiest way to do it. Let's go to C. Probability of selecting a 9 or a diamond. Can you have a 9 or a diamond? Can you have a 9 or a diamond? Yeah, you can have a diamond that is a 9, which means this is not mutually exclusive as there is an overlap. So probability of a 9 plus probability of a diamond minus my overlap, probability of selecting a 9 and a diamond at the same time. Okay, so what's the probability of a 9? There's 4 9s out of a 52 card deck. How many diamonds are there? How many diamonds? There are 13 diamonds in a 52 card deck. And how many diamonds are 9s? How many diamonds are 9s? Well, there is 1 diamond that is a 9. Okay, so I'm going to minus the 52. 4 plus 13 is 17, minus 1 is 16 out of 52. And then that simplifies down to 4 out of 13. Sweet. So those are my probabilities. Again, make sure you have this down. We're going to go on to the next example. You'll more than likely see this on the homework quiz. Wow. On the quiz. Okay, you'll more than likely see this on the quiz and on the test for that matter. But the test won't be for another week or so. All right, so identify the sample space of a probability experiment and determine the number of outcomes in the sample space. You want to find guessing the first digit of a car. I one time had a student's like, how am I supposed to know what the first digit of a car is? Great question. But let me tell you, you should know what it is not. It cannot be one number out of the 10 digits that you have, and that is 0. It cannot be 0. You do not see a car priced at 0 and then like 9,000. You don't see that. So you know it can't be 0, which means my sample space here, my sample space is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? Meaning it's not going to be 0. Okay? It's going to be just 1 through 9, which means how many outcomes? 9 different outcomes. Okay? 9 different outcomes. That's what I wanted to find. So the first thing they asked us is a sample space. So that's my first step. And then they wanted to determine the number of outcomes here, and this is my second step. Okay? Boom, boom. Sweet. Let's move on. This one is not too bad, okay? So don't freak out when you see it. It's just going to be a table. It's going to give you this table of events. So what does this ask? This asks, find the probability for A. So I'm going to go over here for A. Actually, I'm going to put A right here. Okay? A. That looks like junk. I can't live with that. Boom. Okay, so A, find the probability that a randomly selected student is male given. So this is conditional. So when you see the given here, you should know that's conditional. So given that the student is a nursing major. So what is this? My probability is going to be this. The probability of a male given nursing major will equal the overlap all over the condition. So the overlap all over the condition, what's the overlap? Male, sorry, I'm going to do probability. Probability of male and nursing major all over the condition, which is just the nursing major, probability of nursing major. That is my formula. It's just a probability of the overlap all over the condition. So what's the overlap? Male and nursing major. Let's look at it. Male nursing major, it's 93. So it's 93 all over the overlap, which is just nursing majors. So how many nursing majors total? It's 802. So it's 802. And this simplifies down when I plug in the decimals or my calculator. It simplifies down to 0.116. Awesome. That is my calculation. Sweet. All right, now let's go to B. Find the probability that randomly selected is a nursing major given that is a male. So it's kind of flipped. So now the probability that is a nursing major given that he is male. So what is that? The overlap. So nursing major and male all over the condition, just male. So again, this is my formula. Let's get to it. What is the probability of a nursing major and male? We already circled it here. Nursing major and male is 93. Now, what's the new condition? The new condition is just males, right? So not 802, but 1,168. That's the total. So 1,168 is my condition. I simplify this to be 0.0796. Boom. Probably want 4 decimal places. I'm guessing that's probably what they'll want is 4 decimal places. All right. Now, that is that question. Let's erase. Make sure you get it down. You will definitely have a question like this on the quiz. Make sure you understand it. Let's go to the next one. And this will be our last one here. Use the frequency distribution to the right here. And according to the age, find the probability that the voter chosen at random is in a given age range. So not between 35 and 44. Not between 35 and 44. Well, the first thing I need to find when I actually do this, I'm just going to write it out here. I want to find the probability of it not between 35 and 44. Okay? So that means I need to take the complement. Before I take the complement, I need to actually find the total. So what's the total frequency here? Because I need to find the total frequency, right? The total frequency after I add them all up, you can do that on Desmos, you can do it on the calculator. After you add them all up, you get 146.9. This is the total frequency. You need the total in order to do the probability. Okay, so this is going to be 1 minus this right here, the 35 to 44. I need that 23.7. So 23.7 divided by the 146.9. Okay, this will give me everything that's not 35 to 44, and that's exactly what I want. So I can actually plug this in to Desmos, and that's what I'm going to do. So let's plug this. Go to Desmos.com. I'm going to teach you how to just plug it in. Go to Desmos.com and plug this in right here, and then we're going to get a decimal. Okay. So when I go to Desmos.com, I'm literally just going to do 1 minus 23.7 divided by my total 146.9, and this is my answer. I get 0.8386 or around 87. Okay, so let's go back. Make sure you get that answer. Pause the video if you need to. And my answer here is going to be 0.8387 when I round it to the 4th decimal place. Awesome. So we just blew through those 5 questions, but it's good that we should know how to do it, and it's good that you can kind of go back on your video and make sure you have all the necessary things, all the necessary parts, the components. You understand everything that I'm explaining. Awesome. So let's erase this. Like I said, you will more than likely, it's probable, get it? It's probable that you'll see those questions on this quiz. Take the quiz now. You can pause the video. You have 10 questions, 45 minutes. Of course, it is open notes. You do not have any weekend homework assignments except for one thing. So I'm going to explain that one thing to you in a little bit. But go ahead and take the quiz. Remember to review your answers at the end. Send any partial credits to me if necessary. If you do not send me any email, I'm just going to take the grade as Math Excel gives it. But that's a shame because some of you actually get really, really close to the answer and probably could get more credit than what Math Excel actually gives you. So don't let that happen to yourself. Do what I say. Just review your answers. See if you can get some partial credit on some of them. Okay? All right, so hope you enjoy your weekend. Make sure that you have completed everything by 4 p.m. today. If you're watching this on Friday, by Thursday, make sure you complete everything by 4 p.m. on Thursday. Retakes for this quiz, if you forget to take it, or if you just didn't get the grade that you wanted, retakes for this quiz are available starting next week. Actually, are available right away. You have a whole week to take this quiz, to retake this quiz since you took it. So if it's Thursday, you took it today, let's just say you get like a 40% on it. Obviously, you don't want that. You can just email me, yo, Mr. Carlson, can I retake the quiz? I can say, yes, you can retake the quiz. And then I can open it up, and you have a week until next Thursday to retake it. Okay? You're not obviously doing this conditional events worksheet, but what you will be doing is this. So let's go to stats, go to period 4. You're going to go to classwork. You do have a homework assignment. Wow. Okay. Your homework assignment is down here. Look at Unit 7 probability. You're going right below the probability deck of cards PDF that I showed you earlier this week. You're going to click on the birthday problem discussion, and you're going to view the assignment. Really what it is, you're just going to watch this video. It's actually a very, very simple video. Okay, you're gonna watch this video. It's colorful. It's about the birthday problem. It's actually a great question. I know it started. It's a great question and it's a great problem involving statistics and probability specifically. And then you're going to answer these questions. You're just going to answer which part of the video sticks out to you the most. Did you expect the probabilities to be so different? Why or not? Why is our intuition so wrong often? And then how can we be sure to receive the correct answer? What is the purpose of probability? And so forth. So answer these questions at least two to three sentences. I'll probably put that here. Answer it in at least 2 to 3 sentences, and that's it. So watch a 5-minute video, answer the questions, and you'll be done for your weekend homework. All right, guys, that is it. This is C Squared Mathematics. Make sure you like and subscribe. Click the little bell for notifications for more statistics videos. Have a great weekend. Make good choices. I'm out of here. Peace.